Cool. My name is Sundar. That's my email. We'll figure out connections later. Okay. My history started off with a bunch of stuff in 1984, let's say, with technology. And it's kind of interesting how technology evolved over that time. And one of the most amazing things for me when I found out about this thing called RFCs and the request for comment system. Does everyone know about request for comments? It is the most wonderful thing, in my opinion, in the world. Because it goes backwards and forwards in and out of technology. It's a process for how to write documentation. So one of the very early things that I found out about was how to structure documentation around stuff like this, and using raw text, which seemed like a completely insane proposition because when I got introduced to things like Microsoft Word and I can't even remember the precursor to it, it was like, oh, you have a GUI for doing this stuff. Why would you write this in text? But anyway, it was very cool. And there used to be this amazing site that went away, so I had to like look it up on the Wayback Machine to just make sure that I wasn't losing my mind, called Network Sorcery, which actually gave me this whole thing called the RFC source book, which really explained how all of these different protocols work. And protocols themselves started like making me really happy because I was like, oh wow, there's a structure to how all of this stuff works. There's no magic. Because it seems like a lot of stuff that we do just feels like, like some wizardry and genius people are doing this somewhere. But you break it down and it's like, wow, this is very, very logical when you start building it up from the rudiments. And this is the wonderful thing about the OSI stack, right? Like you start thinking about it in the layers that you are comfortable with, and things start actually making sense. And one of the coolest things back in those days, in the late 80s and early 90s, was the cult of the dead cow. Do you guys, how many of you know about the cult of the dead cow? Cult of the dead cow was like an amazing resource on the internet to like basically get anything that you wanted. Like that was back in the bulletin board days. There were incredibly helpful people. Incidentally, Beto O'Rourke was part of this. Mudge, who ended up becoming a consultant for the Obama administration. I mean, they ended up being called hackers later, but these are all people like very good about sharing information. In that, has anyone watched the movie War Games? You know, the one with Matthew Broderick. So it felt like these were the people that the Matthew Broderick character was based on. Like there's this entire network of people that were making stuff. So I was very influenced by that when I saw that movie in like 86 or 87 or something. But anyway, they were really helpful. And then like as I was working more and more, I spent a pretty large stint in the telecom world. In the late 90s or early 2000s, this movie came out. Do you guys know about this movie, Warriors of the Net? It's on YouTube. Ericsson commissioned this to make basically an animation about how packet data works. And it's an amazing video. Like I cannot recommend it highly enough. Anyway, Warriors of the .net. And so as I went through this, I was like, okay, the thing for me is this. Communications just seemed like a freaking insane thing. Like how systems can talk to each other, because I didn't really understand, because everything in the world just seemed like, how can a machine do a thing? How can it talk to another thing? And how can it do all the stuff that it does? And how can humans then get in between this? So, I mean, the beginning part of this is obviously the can and a string thing, right? So you go, oh, you can actually transfer data voice from one side to another and somehow get the other person to get some fidelity of output in this communication. Never 100%, which is also fascinating, which I'll come to, this world of fuzziness. But anyway, in that, when I went into the telecom world, so I grew up in India and in Central Africa, where getting a telephone was a magical thing. Because firstly, the bureaucracy to get a telephone was somewhere you put in the paperwork to get a phone, and you might get one in like 8 to 9 months after you put in the paperwork. And then it was like you pick up the phone and you can call somebody, and I was like, how does this thing work? And when I started working in telecom, this idea of circuit switching was like, oh my God, this is insane. And you see, I saw videos much later of people plugging these things in. But just to have switching through relays seemed amazing. And then, oh, sorry, you'll see these things. There's a lot of distractions in this presentation. So when I went down that slide, I was like, oh my God, somebody actually made this graphic on the internet, and people spend a lot of time making amazing graphics. It has nothing to do with what I'm talking about. It's just like a nice distraction. But anyway, then I got to packet switching, and it was like, oh my God, packet switching is this whole other amazing thing because you don't even have to know where the relays are, and somehow these things know how to assemble and unassemble. And when I started trying to get my head around how sequencing works on the internet, I had a kind of nervous breakdown. And then I was like, oh, okay, like this is kind of cool. And then like I was like, how can I understand this better? And then it got me into this world where, like, so when I worked for this telecom company, it very quickly went into how do you write the software to like make stuff work? And this is in the early days of voice over IP. So I was extremely fortunate to have worked for a voice over IP company right after the MCI, like the lawsuit that went against AT&T in like 1993, I think. And so deregulation started happening, and US dial tone was like provided to the rest of the world, which is a kind of an amazing thing. And like, how does this stuff work? And like you get deeper into this and you go, well, there's a thing that has to happen is somehow we have to call applications in other places. So this idea of how one application can call another application in another part of the world, I was like, oh, this is, I didn't even understand it. But this is where, like, back to Matthew Broderick, when he puts the coin into the thing and is able to like crack into a whole other system, I was like, oh my God, this is cool stuff. How do I do this? And the most important reason for me doing this was because I could run blue screen of deaths on Windows machines, because you could just send a protocol message somewhere else and crash a machine, which ScriptKitty, Sundar, back in those days, I did dumb shit like this. And it was like, wow, you can do this thing like WinNuke, and you can do WannaCry, and you can do all of these things. And this became a thing to kind of understand what is really going on. And so anyway, there's this whole world of weird stuff that happens, but it's really about remote method invocation. So I want to like step back in that a little bit to go, where did this come from? Because again, like I had been doing all of this, and so one of the reasons I wanted to do this presentation was also like get in my head all of the stuff that has happened over the last 30 years in my life, to just go, okay, what is this stuff? So back in the early days, in the 90s, we had a bunch of protocols. I don't know how many of you know Corba or DCOM or COM. These are horrendous, like anti-human, like systems that were garbage. But the intention was really good, because the idea was, how do you call a function in another system, assuming you need security, assuming you need reliability, there has to be some kind of discovery protocol and all of this stuff. So we went through COM, and then Corba, and then DCOM, and then Java remote method invocation, XML RPC, and then like web services started happening, which is a kind of a magical thing, because oh my God, like this is a little bit easier to understand. And we saw things like, the REST, convention. I'm going to use these two words, protocol and convention, very carefully in this presentation. It'll start becoming clear why. So we got REST, and then we got SOAP, and then we had RPC, and we had these things of like how to get systems to talk to each other through some kind of a convention that we had defined. And then we get into like stuff that is, again, slight distraction. Went down the rabbit hole of, oh, you can actually also manipulate human beings using remote viewing. So if you guys are interested in that, remote viewing is a kind of fascinating area of either hand waving or reality, I don't know. And then somehow I came into this thing about a year ago. One of my ex-colleagues goes, you gotta look at this thing called MCP. And I was like, okay. And I was like, step number one, back in my days, is always go back to IANA RFC, no results. So like, what is it? You say it's a protocol, but there's nothing over there. So I had to like go back to Anthropic's documentation, and they give this thing about like what MCP is. And the more I read about it, the less I understood. And thank God for like the internet and things like this. By the way, I also must apologize that you'll start seeing those horrendous green check marks that we all hate so much now, all over this presentation, because I actually used AI to like generate a lot of this stuff. Because I'm also in this mindset right now that I'm going to try as little as possible, as much as possible, not to write anything on my own to see how far I can push the system. It's kind of interesting as an exercise in frustration. But anyway, forgive the green check marks all over the place. But anyway, this is ultimately how I understood this thing called MCP. How many of you use MCP? So it seems like magic to me right now, and it really has incredible potential. So something happens. You have like a chat interface that goes to a client that has this thing that is now able to call a bunch of other things. Now, Script Kitty Sundar goes, oh my God, I can crash a whole bunch of Windows machines this way. Blue screen of death everywhere. Okay, so this is kind of fun. And so obviously my laziness loves this because I just want to tell the system to do this. And as I got into it, it also solved a lot of other things that were in my head for a really long time. This idea of how do you know what the other system is supposed to do? This is true of anything, right? You plug one network switch into another network switch. How do you know whether it's a switch or a router? Yeah, how do these systems like communicate with each other? How does it tell what resources are available to it? Now I plugged it into a switch that is in some network. Can I know if there's a firewall behind it? Can I know if there's a file server behind it? Can I know like a bunch of other things? And then what can I do with it? What are the tools? And finally, delegation. It's one of the worst words in the English language because this is now a system that goes off and tells other systems that it should do stuff, and hopefully it does something. And another distraction, like people have an amazing ability on the internet to create great graphics. I have to say, like when I found this, I was like, wow, like people actually broke down all the ideas that are in my head. And like I started like drawing things out, and 2 hours later, I went and I searched for something on the internet, and somebody had done this with clearly explained on it as well. So it's kind of awesome. And Daily Dose of Data Science is a freaking amazing resource, by the way, if you guys don't know it. Anyway, so what this started really feeling like to me is like this: a very eager puppy that goes and tells a bunch of interns to do something, who go to the IT crowd, that says, computer is completely gonna like break, and it still comes back with a result that I'm like, this is not what I asked for. Like, so this is the whole system, and I've had to like kind of grapple with whether I like the puppies or I don't like the puppies. So generally, because all of LLM says that I'm a genius, I have a tendency to go, oh yeah, this is amazing. Because always like it congratulates me. Oh my God, you're right. You're so amazing. You've done exactly what you expect. So great. I will take the large stick and figure out what to do with it. So, this is my life right now. So anyway, the main point is this is not to talk about MCP. Sorry, like I forgot what the agenda was. So let me actually get back to what we're going to talk about. So the main thing that I wanted to talk about is the sequence that went into my head of like, what is this thing? So we started off with machines that are basically running standalone, and then machines that were able to communicate, and then machines that were able to communicate with human beings somehow. But then the human beings didn't understand what the machines were saying. So like we were trying to understand what was going on behind the scenes. We got lazy, we wanted convenience somehow. All of this will start making sense a little bit as we go. That's why it's very much stream of consciousness right now. And then the machines figured out how to become even more inconvenient as they went. And they've tricked us into like doing something that we think that they're doing the right thing, but I'm not sure yet. So we're kind of in a bit of a mess, but maybe there's hope. Maybe. Okay. I'm probably not going to help you learn anything. So, okay. Maybe you guys will help me. So I had to step back and look at what is this thing about the evolution of communication? And again, internet has amazing graphics. In the world of how to communicate effectively from point A to point B, I love the idea of a smoke signal because there's a protocol that has to get established for this. And this is why it's not just a convention, but there's a sequence like Morse code or whatever. Somehow information has to be transferred from one entity to another entity through some system. And the system may or may not be reliable. So I have to keep thinking through, okay, what do each of these elements in the chain do for us? So from there you get to carrier pigeon, which also is either highly reliable or highly unreliable, depending on how you think about it. But long-term reliability of carrier pigeons is really impressive, to the point where I think a couple of years ago, there was an RFC, actually about 10, 15 years ago, there was an RFC for uh, it was Ethernet over avian delivery, packet data over carrier pigeon, which is kind of amazing that somebody actually wrote the standard as an April Fool's joke. But still, I mean, you can do this, which is kind of amazing. Because initially I thought, oh my God, this is just kind of an onion headline. But then you think about the scale of intergalactic communication, and that's kind of where we are. So in a lot of these things, the joke ends up becoming the reality of like, oh my God, we have to think through how do we send a message out to Voyager, and get it back. And people did this in the 70s before they had all the tools that we have today. Anyway, point in this is that evolution has happened through some pretty impressive stages. And it looks like confusion, but that's only because we can't quite figure all of this out. And so I had to break that down into what does this look like in terms of standalone systems, inter-process communication within a single system, inter-system communication. So this is kind of where my history started, is in the inter-system communication, because right when I started was when local area networks was starting in the late 80s and early 90s. And this is kind of fascinating for me because I remember when you couldn't get two computers to talk to each other. I had to take the floppy drive, do the thing, take it out, put it into another machine, like, and keep doing this over and over again. So my first Linux install was, I think, 28 floppy disks, and it was like, several hours that I spent doing that. I'm like, I don't even understand how I had the patience to do that at the time. But anyway, so as we get into like modern day systems, it starts getting even more interesting because now we have this need for discovery of what the systems are doing with each other. Because now that you've got interconnected systems, you have to know, okay, connected to you, we have Swagger, we have SOAP also had a little bit of a discovery system. Remote method invocation needs to kind of tell the caller what all can be done. And so over time, we get to this AI scale system where LLMs have to start telling you what they're capable of. What is their language model? What is the domain of expertise? And as we do this, it starts getting like pretty interesting, I think. But in my mind, it's always about the telephones because this is where I came from, and this is the easiest way that I can understand how this stuff works is to break it down into what we need to be able to do. Okay, so I break it down into like the manual one-to-one connection. Pick up the phone, the relay gets triggered. I can call the other person. And then the intersystem, electromechanical system started coming in. SS7, I don't know if anyone is familiar with this term. SS7 is signaling system number 7, which is a way to send out-of-band messages over the network to say, this is how you need to connect to the target person for the telephone system. One of the most amazing things, and this is why we even have telephony, like mobile telephony work at all, is because of SS7. It's a broken and completely like unscalable system, but it provided an amazing foundation. And then we have things like voice over IP and AI calling, which we'll come to in a sec. But simultaneous to this within my head, we're going from a deterministic system to a probabilistic system. And by that, I mean that when you connect one person to another person, you know you're going to talk to that one person. In the packet data world, you may or may not connect to that one person. And so the in-between system has to go, how can I create reliability? Okay, so we had probabilistic systems that kind of corrected for how you get to a target, but over time we were able to figure that out. We're now heading to a world where some of that probabilistic stuff is really just like, whatever, we'll figure it out, as we go. Then networks on the internet came. I realize my sequence is kind of going all over the place, but in my stream of consciousness flow here, hopefully everyone will bear with me. Switching back to early 90s, when this network stuff was happening, where local area networks were coming through and how we were connecting to each other, and it was like protocol wars, I had to personally deal with TCP/IP NetBEUI, which is Microsoft standard, Apple Talk, and Novell network. And they all seemed fine. And then it was like somebody told me how to actually read the protocols as I went back, and I would and then I understood, oh, this is how this stuff actually has to work. So my thesis project in my engineering days was to build an Ethernet controller, like an actual physical thing, which I failed at so miserably. It's kind of amazing. And I don't even know how I passed, to be honest. But one thing I got out of it was to understand that you can create a structured messaging mechanism out of just electricity, which is like amazing concept to me. And I went back and I looked at things like serial protocols and stuff like that. So TCP/IP is a very elegant, incredibly scalable, amazing, genius invention in my opinion. Because when you look at the others, NetBEUI, in my opinion, garbage. It's like fine. You have some stuff that you can read, but it is totally unscalable. Apple Talk, kind of cool, but doesn't go beyond a certain number of devices. Novell NetWare, kind of they just made it up as they went along. It felt like, Again, I cannot say enough about how much I learned from network sorcery. These guys helped me to understand a lot of this. And then I was like, okay, how can I get understanding this as I go? So when I worked for a company called 3Com back in the day, they were one of the big network manufacturers. I got to learn things like how to debug this stuff, and there are these amazing tools like TCP dump, Wireshark. I'm sure a lot of you are familiar with these kinds of tools. Um, and, GNU debugger to like figure out what the executable is doing. I mean, these are sort of default tools that we use in order to understand what's going on below the system. But somewhere along the line in the late 90s, early 2000s, this started happening. So I used to be at the IETF as a standards body person with 3Com, and this voice over IP went from like the signaling using like fixed frame protocols to session initiation protocol, SIP, which became the foundation for a lot of the voice over IP world. But it was XML based. And so, like, I remember the fight happening of people going, we need to keep it in a frame format, like length, amount of data, next frame, and so on, to we need to be able to read the data as it goes. And I say said no one, a lot of people like, we need human readable protocols for debugging. And you just go, these are people who were just lazy on some level. And developers claimed they wanted convenience. And they wanted stuff like this, like, instead of using TCP dump to look at the output, because somebody had to write TCP dump, it was like, oh, I need to just be able to read it. I don't want somebody to have to write the tool for me to understand it. But to step back, it's the world of how Unix systems and the world that we know, the underlying plumbing of the system really relied on people making these little tools that were so amazing for all of us to use because that's how it worked. You needed to understand it. You didn't need to make it human readable. So instead of reading logs, oh, I need something that just spits out the logs in raw format. Not that anyone ever reads the logs. So now we build layers and layers of other tools to digest this, and we have things like Grafana and Prometheus and stuff like that. I want to be able to edit it with a text editor instead of using a tool. And as though a text editor is not a tool, it's like kind of insane. And then copy paste into something that somebody can read, which is an even more amazing thing to me because we've had markdown type stuff since LaTeX days way in the 80s, and people were not willing to use those things. Anyway, we had this trade-off of convenience versus efficiency, and it made this thing, this is just a matrix of like how, like the efficiency trade-off was not that great because we ended up not having like significantly larger like framed, larger data that was being sent around. Performance became an issue, and allegedly people were able to read it, but nobody reads JSON files anyway. Sorry, some of us do, but like it's not like all that much fun. Um, so my question is like, do we really need to be able to read VoIP calls? Like, I love this stuff. Like, so in my history was in mobile IP. So when the mobile IP standard came out, I was just like, oh my God, we can make ladder diagrams in raw text. That's amazing. And nobody else cared, obviously. But now we have this amazing tool called sequence diagram generator, and it's like, mermaid tools and all this. So I still use GraphViz all the time, which is why my diagrams look like that. But not everyone loves that, So I'm just trying to figure out how to write an MCP to Miro so that I can get my GraphViz to actually build Miro diagrams that look nicer and then that'll go to Figma, but like right now Figma MCP is broken. So anyway, um, okay, point in this is, again, so the trade-off in this is really, really obvious when you start looking at it in terms of like the size of the frames and the performance impact. Okay, so I think this is relatively obvious, but when you look at the raw numbers, it starts becoming like, oh my God, what are we doing? Like something that can be fixed frame, that then we are going to something that we have to explain natural language to some system that has to come back. But in that natural language system, we pretend that it has to be human readable because it's JSON instead of a frame data that we have to efficiently communicate just little bits of differences from one state to another to an LLM somewhere else to get data back. I don't understand why we're still going down this path. Okay, so much smarter people than me are addressing this problem, I think. But there is a thing that we also need to understand as the end user that this is why some of these systems end up looking slow in some cases, and people are like putting in these interim solutions to kind of make them a lot better. I think Anthropic actually is doing a kind of remarkable job at how this is working, but also OpenAI. Each iteration that I see is just like, gosh, it's crazy how they've been able to make this go forward. But anyway, the point in this was that readability is for debugging. I'm not sure that it was, mainly because we had these amazing tools that made it possible for us to read this stuff. So I don't know how many of you guys use these tools, but they're sort of like the basic tool chest for a lot of the stuff that I work on. Curl with jQuery, with JQ, uh, Charles, which is the debugging proxy. I don't know if you guys are familiar with it. It's super cool to like be able to see messages going between systems and be able to edit it. Burp Suite for security, Postman and Insomnia to be able to send like protocol messages out, and of course Wireshark because it's the Swiss Army tool chest on how you can kill yourself like pretty quickly. So, but I always think in terms of between the client and the server, what is the thing that what tool can I use to understand what is going on? And this is where this idea of like protocols versus conventions started also becoming a little bit more apparent to me. Like, okay, a protocol is something that I know is happening. There's a deterministic system. A convention is something that people go, okay, like, let's talk about this and agree to stuff. And like the big ones in our world right now, or up to now, have been things like TCP, very, very well established. We all use it, TCP and UDP. Sorry, I didn't mean to just have it be TCP. I never want to belittle UDP, but you know, it's the thing that we all use and hate on many levels. But it really kind of defines a formal structure for how data needs to be sent out. And then you get to the next layer, which is REST, RSS. So when RSS came out, it was also kind of remarkable that somebody could go, oh, I'm just going to specify something in order to communicate information about blogs and podcasts. Like when Aaron Schwartz did this in the mid 2000s, I want to say, like 2003, 2004, something like this. It was kind of amazing. And I was like, Atom, RSS feeds, all of this stuff. I was like, why do we need this? And then the moment he did it, it was like, oh my God, we really needed a convention around this. And conventions are super important because then once we agree to it, this is great. So then, like when you get into these other kinds of patterns like webhooks, to be able to do this, you go, oh wow, there's actually a mechanism for us to communicate between different systems. And going back to this idea of communication, you don't have to have it be a strict protocol, but you at least need to understand the difference between a protocol and a convention. Because once we agree to the convention, amazing. This is like law, right? Like for me, law is convention and protocol is like physics, you know? So you have protocol, but if you don't have the convention, we can't do anything. And in our industry, in the AV experience design, creative technology industry, I feel like convention is a thing that we need to kind of define a little bit more. Laura, we need another book. Yeah. But say again? Will you help? I'm in. Yeah, let's do it. So I started getting into this thing of like deterministic versus probabilistic thing. And this is something that's been bothering me for a little while, actually. This is not just for this talk, because this idea was we can have this thing, binary data, or a structured format, even if it is something like XML. But there's a certain amount of probabilisticness in the way that the internet works, in my mind, because we were able to correct for errors within the system and go, let's bring things back into alignment if frames go out of sync or whatever, you know? So, but we took this to the next level now because as part of it is because we don't have a choice, because going back to things like smoke signals, you kind of have to go like, in order for humans to communicate at the scale that we do, we have to come back to a probabilistic model. But it seemed like the evolution of protocols and the kind of the migration towards probabilistic systems worked hand in hand. Okay, so this is my theory. I could be 100% wrong. Probably am. I usually am. So I'd like feedback on this. So that also got into this idea of debugging. So for me, as an experience designer, the most expensive part of experience design is maintenance. If I can figure out how to get a maintenance contract and not do anything, this is great. Amazing. Hasn't happened yet, but I'm working on it, you know? But I need to be able to debug when something goes wrong ahead of time, proactively fix it, and then like be able to move on with my life. So in the traditional world, I was able to write code, sometimes in Unity, which is its whole probabilistic mess. But like you make an application, you set it up, you run it, and there may be bugs in the code, but you know how to debug it because there's logs, and you can do a debug trace, you use GDB, whatever it is, and get to somewhere that I can fix it. Now we're encroaching on this world where it's it's not even a best guess. It is a I have no idea. And this is where I don't think that this is something that is unique. I think every system sort of starts like this because we didn't know, for example, when Ethernet was made, that electricity could be reliable up to a certain point. And as we get into more and more large scale systems, we also realize, quantum effects start coming in and we have to grapple with some of this stuff. But we came up with tools to reduce um, the problem, the error space, let's say. So anyway, this is the world that we're heading towards. And in my mind, MCP is closer to smoke signals than packet data protocols because all the environmental effects that we have to grapple with are the things that we have to like get to now. Anyway, so this is the problem. Can't debug that MCP. So the traditional tools that I showed you just kind of don't really work. Wireshark, great, gets to a certain point, but I don't know what the other side of it. I don't even know how the Wireshark team is going to think about adding these kinds of features because I'm sure they are. A lot of very, very smart people that are kind of trying to figure out how to solve for this because it's an obvious one, right? And they have to solve for it because otherwise people will lose faith in the system and the trillions of gallons of water that we're, destroying every day will be for naught. Um, yeah, Charles, Brook Street, all of this stuff. And I deal with like for the last few years, I've had to really deal with the lack of security in the AV and experience design infrastructure world. But I was able to solve for it because it still was very deterministic. Now, if I put an LLM, let's say I put an MCP server that runs on a MikroTik box that's running inside a network to like do a bunch of stuff in an experience design world, God, this opens up the channels for all kinds of nefarious activities, which again, uh, Script Kitty Sundar would love that. But anyway, all right. So what MCP doesn't have yet. So as I went through this, it's also the language around this starts becoming more and more weird because we now need to have things like an intent analyzer. This kind of language is not what we're used to. Okay, we're used to it from a end user experience perspective, in experience design, but an intent analyzer, a prompt debugger, a behavioral replayer, like these kinds of things are using language that are around like, stuff that we don't have empiricism around so far, but we have to kind of figure out how to make them converge to empiricism. And then you have things like a trust verifier. So in some cases, you have this. In GitHub, you have this. So GitHub Dependency Manager, I don't know how that works for something like an MCP server because it's behind a firewall. How do you know what it really does? Like it just says what it does. And then you need a probabilistic test framework that goes, okay, is it 100% reliable? I mean, we've seen this already with, not to label China, but like the one incident where a Chinese gentleman got trust within an open source project and for years was doing great work, but he was actually a Manchurian candidate. Actually, funny, like a Manchurian candidate. I only now made the connection between China and Manchurian candidate. Anyway, Manchurian candidate in the system that ends up like becoming like a proxy to add nefarious code into the system, and somebody accidentally catches this. That's not good enough. We all know that it's not good enough, but we don't know what the solution is. And to go with a non-trust system is also horrendous because it's not great. I don't want to go to 1984, although I came from there. Okay, so laying it out like this as a matrix, it also is helpful to just see we have some tools that can help us to some degree, and then it starts getting incrementally more complicated. There's a better graphic than this, I'm sure, but okay. So this idea of protocol versus convention, hopefully now I start understanding why I'm even like being so, why I'm pushing this idea, because we need some way of, as we get towards either a convention or a protocol, we have to define what this thing with the way that we talk between these different systems is, as these systems become bigger and bigger and bigger. So this is just it's a thought experiment on some level, but we have to kind of get to something and give MCP and systems like that a higher score for how we do these things. A lot of them are solvable. Some of them, maybe we have to think a little bit out of the box, but that's, a lot of smart people in the world that are thinking about this. But sorry, one thing I will say about this is a lot of smart people are thinking about this from the Silicon Valley objective of making money by destroying the planet. But in our world of storytelling, this is even more important because I think these are amazing tools to tell stories in ways that we have not been able to, or stuff that we've wanted to do for a long time that now open up like possibilities that we just have not really grappled with so far. But as an industry, I think we need to kind of define some of these. Hey, Laura, there's another book that we need to write. Um, but uh, but anyway, um, one of the great things in the system is discovery. So um, discovery was sort of the big, let's say it was the big problem in a lot of systems when I was trying to understand how these things work. When I connected a computer to another computer, how do I know what the other computer is capable of doing? Why can I not get a Mac? Like this dumbest things. Like back in the early days, if I had a network and I connected an Apple machine to a Windows machine, they couldn't talk to each other because Apple only did Apple Talk and Windows only did NetBEUI. And I was like, I don't understand why. And then you realize people are fucking stupid and evil. But like the discovery process is the kind of interesting part of this, and it can be honest or it could be full of life. So one of the cool things in MCP and in remote method invocation systems is to go, oh yeah, somewhere system says, tell me what you have to do, okay, or tell me what you can do. It responds with a bunch of stuff, and it says, I can do all of this stuff, but then it can legitimately. I have had this happen where you tell the LLM, do not delete files in this folder. Files all go away. And you go, I told you not to delete the files in this folder. Oh, the files got lost. True story. Funnily, it happened to me the day after that big, public announcement of like some company that had lost like, all their source code or something like this. And I was like, oh, this is interesting because I had gotten into the habit of putting everything into Git a long time ago. So it saved me because I was just like, it's easy to also forget because most of the time you're doing this at 3 a.m. And then you're just like, because I'm lazy and the rest of the time I'm trying to play. But anyway, so it gets to this idea of like whether these systems are actually evil or potentially evil or whatever evil means, because Google claims that they're not evil anymore. But MCP is evil because of a lot of these things. And I think it's worth understanding what each of those things are in reality, not just in terms of, oh, LLMs hallucinate. Because I hear this all the time of like people like, oh, I don't use AI because it hallucinates. I'm like, do you understand what that means? The more precise you are about this, it's just a language model. You hallucinate. When I tell you to do something, you read a book by, I don't know, Jean Le Carré, and you think that's real. This is nonsense. It's not real. Historical fiction is fiction. But oftentimes we conflate these things, and that's what these systems do. Great. So let's start understanding what that is. And this is where the sweet spot starts happening. It's like, okay, you can now analyze patterns. Amazing. Like the levels to which I can do this are really great. Integration, code search. Like there's so many things that we can do with this. This is very much from a technical perspective because I'm still trying to grapple with how we do this in the experience design world. So this is what like I'm actually going to keep working on this thing to go, what do we need to be able to do with this? And so what we're coming to is really embracing probability. So when MCP launched a year ago, which is freaking insane, year and a half ago, we had a bunch, like the fact that this is a convention that has been adopted as quickly as it has is kind of remarkable to me. So we have to get to this thing, verification and sandboxing. This is not negotiable. We absolutely have to do this. And everyone knows this in the industry. And eventually we're going to get to formal methods and standards. But in this world, we also have to feel comfortable that we kind of don't know what we're grappling with completely. So back to this idea of protocols versus conventions, determinism versus probabilities. We have a set of things that I am having to digest for myself. I'm going to throw it out as a manifesto of sorts, really crappy manifesto, but there you have it. MCP is here to stay. We don't have a way around it. In fact, it's actually a pretty good thing on some level. Get comfortable with Git for everything. If you don't have Git, you don't have version control. I don't know of a better version control system out there. It is amazing. It just does stuff. It's awesome. Markdown, you may hate it, you may love it. It helps. And then having Markdown go to diagrams, which is how I did all of the diagrams in this, which is kind of amazing. And then I wish there were better tools. I really spent a lot of time trying to get my drawings in Figma because I love using Figma, but it just Figma MCP doesn't work. I've just been talking to the lead development team at Payload CMS, who were just bought by Figma a few months ago. They know this problem. I keep badgering them about it. Hopefully something cool comes out of it. I realized it's actually made me write better specs, which is ironic in a way because my laziness should not allow for this, but I actually found that this is greater. And like writing with global templates is even nicer. And this is an interesting one because I was like, tell everyone that you're using AI. Because in a way, this is it. We don't have a choice. Like there is no reality going forward where we don't use these tools. But we have to be honest with each other and be very, very transparent and go, here's the spec that I got this from. Here's the prompt. And put that into a Git repo and make that public. And so that we can start understanding how these things work and really, whatever, embrace the chaos. At the end of this is all about the storytelling, and we're all comfortable with this idea of storytelling. Now the stories keep changing as you go. It's okay. We'll figure it out. Maybe every 5 minutes even. So that's a whole other world of like trying to figure this out. So I'm gonna leave you with one last thought. These are the books that made huge impact in my life, and some of these actually gave me the history of how a lot of this stuff worked. I cannot recommend these highly enough. I recently just finished We Were Burning, amazing book about Japanese history of LED manufacturing, electronics, and all this other stuff. Colored Dead Cow is amazing. Where Wizards Stay Up Late is maybe one of my favorite books of all time because it actually tells you the history of how a lot of the protocol people kind of came about. And somehow, weirdly, I made that. We have what, 20 seconds for Q&A? 2 minutes. Sorry. Yes, sir.
Yes, really amazing. Appreciate this. I love your train of thought. My question is, have you looked at all about outside of SLMs, small language, more targeted small language models that are quicker and less likely
Yep.
to hallucinate, and then also some of the new network solutions that I'm starting to see that were developed for IoT, but now I'm starting to see them used for agents and MCP, things like Tailscale that are VPNs, but they're not traditional VPNs like we used to.
Yeah, so I had strongly been using zero tier. I don't know if you're familiar with zero tier. Zero tier for me is like amazing. Firstly, because it's open source and like their code is so well written, but it allowed, so this is where I started getting scared because I was like, so we were able to do some experiments at the Museum of the Future where I used to work, where we basically exposed the entire inner network to the outside world with like over public cellular infrastructure for people to be able to control the inside of the building. And it was, the intention was that. And then it was like, how do you enforce security when something like that happens? And so we were able to do that. So I just had to think through how this stuff works. But like the deeper we were looking, Tailscale introduced some levels of complexity, but yes, we started looking at that. The small language model stuff I've been playing around with, to be honest, like so LLM could be transposed with SLM in all of these cases, but I do like the idea of trying to figure out how the language models can go local. And I think that is the direction that a lot of these systems are going to go down because of data sovereignty and all of these other, and also because systems crash, as we have seen. Apparently Amazon is not, up all the time. But a very little, to be honest, but I have been experimenting with this. So if you have any insight, that would be
extensive.
it'd be great. So I mean, that's my problem is when I look at this, the time frame in which a lot of this stuff happens, even just for myself, I'm just like, oh my God, it's been 16 months that I've been working on this. And like at no point in my history, like, and the previous was 20 years. And it's like just every day I feel like I'm going down this path.
All right, it's a paraphrase kind of statement that I want to about this question. And we've been working on a project recently this week, so there's been a lot of like us talking and then us trying to make sense of something. So it's kind of the theory with all this change in the last 16 months, it's what can we learn from these classic communication models like the telephone, protocols, conventions, et cetera, to help us better steer how we use AI to protect us, to inspire us to work. And like, with all this change, it's like, let's go back to these,
Mhm.
am I understand that? Like,
This is a great statement if you're making that statement.
I'm trying to distill what I heard.
Yes, okay. So the way,
What you said.
so this,
I think you said that, I'm trying to like paraphrase that, is that accurate?
yeah, I will lie under that bus. The, so it just incidentally, because I came from having learned systems the way that I like, just because of the time frame in which I was learning this stuff. I would say Unix is the foundation of our world in many ways, right? Because just the way that we think about these systems communicating with each other, this is where this came from. So even if you look at something like Node.js or NPM or something like that, they're little systems that are supposed to tie to each other. In a weird way, NPM is trying to resurrect a lot of the Unix type of thinking about, how the GNU subsystem worked. So in my mind, when I see MCP, a lot of the people who are building these are being influenced by the history. So it was a very, very strong history. It won in amazing ways. TCP/IP is relevant even today, much more so than Novell NetWare. So I think the people who look at these open systems really understand that those seers, those freaking geniuses of the 70s and 80s, are the ones to look to for like the framework that we're going forward with. So I would say like learning what happened before really is the foundation for where we're going.
We do have to call it. It's time,
Okay.
it's almost time for the next session.
Cool. Thank you all so much.